In the next section, 2.7, what we're going to be doing is instead of finding something like f prime of 2 or f prime of 3, we're going to be looking for f prime of x. So we don't know a specific value for x. We're just trying to find the derivative in general. And what we're going to do for this, so we're actually going to use the same formula that we were using in 2.6, although we're specifically using that h goes to 0 formula. So we're going to use the limit as h goes to 0, but instead of f of a plus h, because we don't know what a is, I'm going to have f of x plus h minus, and instead of minus f of a, it's going to be minus f of x all over h. So the formula is the same, but instead of an a, or instead of a numerical value for x, we're just going to leave it in terms of x. So if I work on this problem here, so find f prime of x, and that's how I would read that, f prime of x for 3x squared minus x plus 1. So we need f of x plus h. We already know what f of x is, so f of x was given to us, but I do need to know what f of x plus h is. So I know that f of x is 3x squared minus x plus 1. F of x plus h, so we're going to plug x plus h, that whole expression, we're going to be plugging that in for x. So instead of 3x squared, I'm going to have 3x plus h squared. Instead of minus x, I'm going to have minus x plus h, and that plus 1 is still there on the side. Okay, so same idea, but instead of a's, we have x's. And then let's go plug this back into our limit expression. So I have the limit as h goes to 0. F of x plus h is that expression that we have written over on the side. So that whole thing was f of x plus h. Now I need to do minus f of x. And be careful, make sure that we put parentheses around the f of x. We're subtracting the entire expression. And we want to make sure that we don't mess up any negative signs. So make sure that you put parentheses around the whole thing. But now after this really feels like what we were doing in section 2.6. We're going to need to multiply it out. We're going to need to simplify it. So let's multiply this out. Don't forget to FOIL. Don't forget to distribute negatives. What we're going to find once we get to the simplifying step, we're going to have a lot more that simplifies than we did before. I'm going to write this all out before I simplify. I know I'm running out of space on the board, but that's okay. It's all over H. So if we look at what simplifies, now a lot more is going to drop out than before. So I have 3x squared minus 3x squared. I have a minus x with a plus x, and I have a plus 1 with a minus 1. So a lot of this stuff is going to reduce out. So if we take a look at what is left, and I'm going to switch to a new board. Okay, so this is what we just had, and if I simplify this a bit, I have 6xh plus 3h squared minus h on top, and everything else dropped out, all over h. We know that we need to factor and simplify. Just make sure when you factor the h out of the negative h, you're left with a minus 1 as a placeholder. Just make sure that doesn't get dropped out. So I have 6x plus 3h minus 1. And now, if I let h go to 0, I'm just left with 6x minus 1. So now my answer, instead of being a number like it was in 2.6, now my answer is an expression or an equation. So what we would say is that for the original problem, which was 3x squared minus x plus 1, we can say that its derivative, f prime of x, is 6x minus 1. And we can use this for a few different things. So if I did want to know what the derivative was at a specific point, I could use this expression, 6x minus 1. So if I wanted to know, like, what is f prime of 2? Instead of going to section 2.6 and doing that entire formula out, I can just plug 2 into this derivative statement for x. So this is going to be a bit of a shortcut when we are looking to find the derivative at multiple values. So if I wanted to find f prime of 0, I could plug it into here. Instead of going back and doing that whole thing out from section 2.6, we can find the derivative in terms of x, and then we can use that to evaluate at specific points if we want to. So if I want to do a different problem, so if I have f of x equals 2x cubed plus x, and if I want to find f prime of x. So I'm going to do the same setup. I need to do the limit as h goes to 0, f of x plus h minus f of x all over h. So for f of x plus h, and for this, if I do it on the side, so I know f of x is the original equation. So I know that f of x plus h is what I get when I plug x plus h in for x. I know I'm going to have to cube out the x plus h cubed, so make sure you're foiling that. Let me get this started over here. So I have limit as h goes to 0 of 2x plus h cubed plus x plus h. So all of that is f of x plus h. Now I need to subtract f of x, and I'm going to subtract the whole thing. Don't forget to put parentheses around it, all over h. Now I happen to know the shortcut for foiling out x plus h cubed. If you don't know, then you're going to have to do this on the side, actually FOIL that out 3 times. Oh, it said 3, so I wrote 3. X plus h. So what you would do is you would FOIL this all the way out and then distribute the 2. So the exponent comes before the distribution, so make sure you FOIL out first and then multiply 2. But when you do FOIL this out, we should get this expression, almost. This should be a square, not a cube. So that's what we get. If we were to multiply this out, we would get x cubed plus 3x squared h plus 3xh squared plus h cubed. Now this plus x plus h, I really don't need those parentheses. And I do need to make sure that I distribute this negative all over h. So if I keep going, so now I distribute the 2. And I can see that the plus x and the minus x are going to reduce out, but I'm just going to do it all in the next step anyway. So what we had in the last section is the constant term on the end needed to reduce with things that came before. And something similar is going to happen here. The f of x terms, the 2x cubed and the x, these are going to reduce, minus x and plus x. Okay, so what we're left with, and I know that I'm going to have to factor out an h, so I might as well do it now. So I have 6x squared plus 2h squared. Oh, I skipped a term. Sorry about that. So I have 6x squared, if I factor the h out of the 6x squared h, 6xh squared, if I take out an h, I have 6xh, plus 2h cubed, I'm going to have plus 2h squared. And then the plus h, if I take out an h, I'm left with a plus 1. So I know I did 2 steps in one there. Hopefully we followed okay, but I reduced those h's. And then when I look at what's left, so I have the limit as h goes to 0 of 6x squared plus 6xh plus 2h squared plus 1. And if I plug in 0 for my h's, I'm left with 6x squared plus 1. So that would be my answer. So from the original problem, we had f of x equals 2x cubed plus x. And we can say that f prime of x is 6x squared plus 1.